At the top of the world, the temperature ranges between 0 and minus 40 degrees Fahrenheit. Over the past 10 years, dramatic changes to the atmosphere, ice, and Arctic Ocean have occurred that could affect temperatures over the rest of the planet. In an effort to better understand these changes and unlock the secrets of global climate change, an international team of scientists funded by the National Science Foundation has established a permanent observatory near the North Pole. Team member Kelly Faulkner explains.
We're up here monitoring. I like to think of the analogy of a heart. Heat gets pumped up to the Arctic and fresh water gets pumped down. And exactly where that fresh water in the form of river water and ice melt ends up back down in the Atlantic Ocean has a strong impact on how the ocean circulates and on our climate. In addition, the other aspect up within the Arctic is the ice cap. So those two issues are at stake right now. So we're sitting here monitoring it right at the source.
For the fourth straight year, a team set up camp on the sea ice to deploy buoys, retrieve a 2-mile-long mooring, and take samples from the Arctic Ocean. Team leader Jamie Morrison explains.
So we install a drifting station, but it's an automated station using drifting buoys that install in the ice and which transmit data from sensors in the ocean and the ice and the atmosphere through a satellite link to our offices.
While these buoys float with the ice pack and eventually break up, the mooring is located at a fixed position under the ice, according to field engineer Jim Johnson.
First year we flew out to a site, set up a small camp, and then melted a hole through the ice with hot water apparatus system that allows us to cut a 4-foot diameter hole. Once that hole's been opened and we have access to the water, we set up a tripod over the system, or over the hole, and we start lowering our array, starting with the anchor, and then just adding instruments to the line as we lower down.
The mooring, 14,000 feet in length, stretches upward 2.5 miles from the ocean floor where it is anchored. Chained to the line are 17 oceanographic instruments. Describing the arrangement, Jamie Morrison.
Cable starts at the bottom with a big pile of anchor chain and extends up through the water column where we have current meters, sensors to measure ocean temperature and salinity strung along the way. And at the very top, an upward-looking sonar which measures the draft of the ice.
In addition to the buoys and mooring deployed this season, team members, using a small aircraft, set up stations along a line stretching several thousands of miles. At each station, they drilled a hole in the ice and ran a cable carrying instruments down 3,000 feet. The instruments tested water temperature, salinity, and oxygen content. Though it is still too early to predict the future of global climate, the team has seen changes. Again, Kelly Faulkner.
And the big changes are basically that the water coming in from the Atlantic Ocean is a lot warmer than had ever been seen before by several degrees. And then the upper waters, which insulate the pack ice here that we're standing on from that heat, are also changing. And that insulative layer in certain places has disappeared and come back, so we're trying to keep an eye on that whole picture.
The team will continue to track and analyze the data being collected at the North Pole Environmental Observatory and prepare to return next year to retrieve and deploy the last set of instruments in this 5-year project.